Alright everyone, hello. I'm going to be going over section 6.3, which is vectors in the plane, for those of you that were working on map test, or those of you that just need to review it. So before you actually watch this video, you should read the introduction to 6.3. That's on page 424. So right now I'm going to start with example 1, but if you haven't this is mostly for those of you that were taking the map test. For the rest of you, I know we went through the introduction, so you should be fine just starting with the example 1 here. But if you didn't, then I suggest you read the introduction and then watch this video. So here we're going to get started with example 1. So example 1 has us verify equivalent vectors or line segments. So this one's going to be on equivalent directed line segments. So all we're going to be doing is we're going to be given two line segments. So the line segments they give them to us on a graph or on a plane, and they draw them for us. So here's one, looks like this. They give us the initial point and the terminal point. So the initial point is at 0, 0. The terminal point is at 3, 2. And then the other segment or line segment looks like this, where this one has the terminal point at 4, 4 and the initial point is at 1, 2. And then they call this one U and V, this one V. So they want us to verify that they have the same magnitude and the same direction. So direction is like pretty much their slope. Magnitude is pretty much what's the length of these vectors. So if you notice, we can kind of form, we could form a right triangle if we wanted to, and the length of this vector would be like the hypotenuse. So when we find the magnitude, essentially we're finding the hypotenuse of this triangle that we would form. Okay, so let's go ahead and find the vector, the magnitude of these vectors. Before we start, this point right here is P, this is Q, and over here this one is R, and this is S. Just so that we can see that these points are labeled. That'll help us kind of keep in mind what we're working with. So first we're going to find the magnitude of line segment PQ. Okay, so here's the line segment PQ, and to find the magnitude of that one, we're going to use the values here that they gave us, and we're going to find the difference. So we have 3 minus 0, and then the other one is 2 minus 0. Okay, and essentially it's like finding the hypotenuse, which I had mentioned before. So when we find 3 minus 0, that's like our y direction right here. When we do 2 minus 0, that's like finding our x direction. So we're finding like the height and the base of this right triangle if we were to construct one. So once we keep going, then we get 9 plus 4, which is equal to square root of 13. All right, now we're going to find the magnitude of RS. RS, so that one is going to be 4 minus 1 plus 4 minus 2, and then we're going to take the square root, and we're going to get 3 squared, which is 9, 2 squared is going to be 4, and we get the square root of 13. So here we verified that both have the same magnitude. Another thing is that this is really the distance formula right here, what we're using, the square root of y2 minus y1 squared plus x2 minus x1 squared. It's the same thing pretty much we're using here. All right, now we're going to go ahead and find the slope of PQ, line segment PQ. So that's going to be the same thing, y2 minus y1, which is going to be 2 minus 0 over 3 minus 0. So that's 2/3. And now the slope of RS is going to be the same thing, y2 minus y1, so that's going to be 4 minus 2 over 4 minus 1. So that's going to be 2 over 3. So now we see that both of them have the same, oops, let me move this up. Both of them have the same slope we see right here. And now we've verified that these are equivalent. So they're equivalent when they have the same direction, in other words, the slope, and the same magnitude. So here we've shown that. So that was example 1. So whenever they ask you, show that they are equivalent, this is what you're going to be doing. Now, the next section is going to be on component form of a vector. So the component form of a vector okay, that's just when you write, it's written as, let's say we're talking about a vector v. By the way, when you see a letter that's bold, that means it's the vector. So vector v, the component form would be written like this. So v1 is pretty much like your x direction. v2 is like your y direction. So these are found after you've found the difference. So up here, we kind of were doing that when we were using the distance formula. So what we did right here, 4 minus 1 and 4 minus 2, we were kind of finding the component form of a vector. We'll go through an example right now so that you see what I mean. So that's the component form of a vector. And let's say that we're given, for example, you have a vector u and a vector v. We're going to find the component form of those. So let's say example 2 here. Example 2 is going to be finding the component form of a vector. All right, so let's say it tells us find component form and magnitude of the vector b. And this has initial point so initial point 4, 7, 4, -7, and terminal point -1, 5. All right, so all that means is that if you were to draw this right here, if you were to draw this vector, the initial point would be at 4, -7. So let's say somewhere down here. And the terminal point would be at -1, 5. So let's say somewhere up here. So your vector would look something like this. Okay, so this is 4, -7, and 1, -1, 5. Oops, sorry about this. I'm gonna keep kind of noticing that I don't scoot it up a little bit. So here's our vector with terminal point -1, 5 and initial point 4, -7. So now we're gonna find the component first. So to find the component, we need to do, so let's go ahead and say component. First we need to find v1. So remember that the component of a vector is written like this: v1 comma v2. So this is going to be v1 v2, and first we're going to find v1. So v1 is equal to the first the second x value minus the first x value. Alright, so we have our second x value is, we need to look at the terminal point, so it's -1 minus 4, and that's going to be equal to -5. Alright, for v2 we need to look at the y value, so we need to do this, the second y value from the terminal point minus the first y value, so -7, and that's going to give us 12. Okay, and now our component is going to be v equals -5 comma 12. So notice how our component form consists of the x value and the y value. So it's similar to when we write a coordinate. So that's the component form of the vector. And now when we find the magnitude, we're going to use these numbers. Since we already found them, we're going to just use them and find the magnitude. So our magnitude, let me go ahead and start over here. Okay, so we're right here. So our magnitude is going to be vector b magnitude. Since we already found the difference of the x and y values, and we just need to square them, so it's going to be -5 squared plus 12 squared, and then we're going to square root them. So we're going to get 25 plus 144, and that's going to be 169, which is equal to 13. Alright, so the magnitude of v is 13, and the component form is -5 comma 12. And that's the second example. I think that's what we ended up going through in class. Alright, so next one. The next one would be vector operations, but I already have the other video on vector operations, so just go ahead and click on the other link if you need the video on that, and I think that should help you with the homework. Alright, see everyone tomorrow. Bye.